This cello is made of carbon fibre instead of traditional wood. Some believe this newer carbon version has a more powerful sound than the wooden instrument. It still has that characteristic sweetness, but is considerably louder. And after all, every musician wants to be heard. The carbon cello is the masterstroke of a Boston symphony cellist who noticed waves resonate loudly against carbon fibre bolts. The top piece of the cello is cut from fabric that's woven with carbon strands. This material is stronger than steel, yet electric shears easily cut through it. Numerous top cello pieces are cut out and then set aside while work continues on another section of the instrument. Special resin is brushed onto a fiberglass mould of the cello's back, ribs and neck. The mould has been pre-waxed to keep the resin from sticking to it. The idea is to saturate this large piece of carbon fabric with resin as it's tucked into the curves of the mould. It's smoothed down to get rid of any bubbles that could affect the cello's tone. More resin is brushed onto the other side of the fabric. Any surplus is sponged away. And then, to build a laminated carbon fibre shape, more fabric and resin layers are added. The layers are covered with nylon-like material, and the edges of the carbon fabric are trimmed. Next, perforated plastic is placed on the nylon, and absorbent batting is piled on top of that. A vacuum pump is installed, and a large plastic vacuum bag is draped over everything. Then the vacuum is activated. It sucks out the air and any excess resin. The perforated plastic controls the amount and the batting absorbs it. While it's still under vacuum, the whole thing is put in an oven to bake the carbon fibre layers together. After the batting and plastic are peeled away, it comes out looking like this. The layers have fused together, and the shell has a sleek look to it. The cello's top piece is laminated in a mould and baked until it's also hard. Using a bandsaw, the ragged edges are trimmed off and sanded for a smooth finish. Now the cello top piece is clamped onto a fixture that has stencils on the back. With a router, they cut out the stencil shape. The sound will eventually emanate from these F-holes. The company label is glued to the inside of the cello's back section. Then, glue is added around the top inner rim of the cello. The back is taped tightly in place while it hardens. Next, the laminated carbon fingerboard is glued to the neck of the cello. Holes are drilled into the peg box, and pegs which are used to tighten the strings are inserted. Soon, this cello will be more than just the shell. Coming up, they raise the curtain on its inner workings. The story of this cello has many layers. They're all carbon, and now the layers have hardened into the shape of a concert instrument. At this point, you can't make music with it though, because the inner workings have yet to be constructed, a process that's a carefully orchestrated performance. The cello frames need a bit of bodywork. They're roughed up with sandpaper. Then a polyurethane clear coat is sprayed on to protect the surface. Then it's over to the string specialist, called a luthier. He sets a roughly cut wooden bridge on top of the cello and measures the position. The placement of this bridge needs to be exact because its job is to elevate the strings and transfer their vibrations to the instrument. Using a grease pencil, the luthier maps out the position of the bridge between the F-holes and then sets it aside. Now he slips the wooden sound post into one of the F-holes and wedges it between the front and back of the cello. The sound post is crucial. It will strengthen the cello and couple the strings' vibrations between the front and back of the instrument. This is delicate and highly skilled work. He measures to determine if the sound post is on the mark. If it's off by even a millimetre, he adjusts it a bit more. Afterwards, he double-checks the bridge's position. Then, with a red grease pencil, he colours over the spots where the feet of the bridge are to sit. He presses the bridge's feet into the grease marks, and this makes red smears on the feet. The smears tell him where to shave the wood, so that it will fit perfectly onto the cello. The bridge doesn't get glued down. It's held in place only by the tension of the strings. Next, the luthier makes pencil marks on both tips of a measuring stick. He leans the stick against the bridge at the same angle as the strings that will run over it. He then transfers the pencil marks from the stick to the top of the bridge. He rounds off the marks by penciling around a template. And then he carves the bridge down to size. He planes it down to make it thinner. With a file, he cuts grooves to cradle the strings. Now, he moves to the bottom of the instrument and slides a spike called an end pin into a pre-cut hole. The end pin will rest on the floor, steadying the cello. He lassos the end pin with plastic rope, which is attached to the tailpiece. And he rests the tailpiece on the belly of the cello. He pulls the steel strings from the pegs and hooks them onto the tailpiece. Like most classical string instruments, the cello has 4 strings. Now, the strings are slid into the grooves on the bridge. The pegs are turned to tighten the strings. The strings push down on the bridge, holding it in place. Then the cello is tuned, and it's now ready for a full-scale performance.